Yes, welcome to this webinar of the Chemistry and Material Science Master Program. So I'm Kari Laasinen, and I'm now the person who is responsible for building this program. And we will have first, let's see, a little bit introduction of Finland and Aalto University, and then we concentrate more to the program itself. And I hope if you have questions, then please ask them. What is more convenient? You should put the questions to the chat, or is that more convenient? Because I don't see your faces, so I don't know if you can of course technically raise your hand on the screen, but well, try to be active in some way. Yes. Yep, this, okay, I don't mention, that's myself, and I'm a professor in physical chemistry, and we are now renewing this, our teaching. We used to have the chemistry master program and material science master program, and we are now merging them, so you'll see. Okay, yeah, Aalto University is kind of both old and new, not old, but relatively old university, a new university. So in 2010, we merged a few schools like Helsinki University of Technology, University of Art and Design, and Helsinki Business School. So Aalto is fairly, it's a multidisciplinary school, and this is one of the strengths of our school. And well, most of the schools are interested, universities are interested in the rankings, so we do quite well. It's important, in my opinion, that we are very multidisciplinary university, and we are also very relatively international. So definitely, this is an interesting environment, an interesting place for students, and especially for foreign students. And what else? Yes, so we merge, as you understand, the science, technology, science, and business and design. So that's this kind of logos. And what is one of the advantages in Aalto is that we have a single campus. So all it's very convenient. All the lectures are within a walking distance. So of course we have one building or two buildings for chemistry school. But then there's a physics and mathematics department or teaching is just the next building. So this is a very compact campus. So this makes the practical studies very convenient. And this has a good connections to nearby. We have a metro station and soon a tram station. So it's easy to reach the campus with public transport. And it's just Aalto, it's just very close to Helsinki, so all the facilities and attractions in Helsinki is close. Luckily, not too close, but still very close. Okay, maybe we talk a little bit the student life. There's one other transparency a bit later, but I think Finland is a very typical Scandinavian country, so we have a low hierarchies. The life is well, compared to many other countries, quite relaxed, and very importantly, Finland is very safe. So in many respects, no natural disasters. Yes, Finland is officially the happiest country in the world, and typical Finnish attitude, we have hard to believe that, but that's a little bit. But yes, that I said, safe and clean environment. Let's see, maybe we skip these rankings now, but then we can get, okay, so this is just the starting slide of so as I mentioned, we combine the chemistry and material science. So of course the first question is why to study, or why this is you might find this our program interesting. Of course, we have difficulties to compete in pure chemistry. Our chemistry major was also very popular for foreign students, but clearly there are huge amount of chemistry department programs in the world. But I think there are of course some, but not too many, that combines the chemistry and material science. And this, I think, is one of our strengths. And we differ a little bit from traditional chemistry department because of course, we teach the chemistry, we do a lot of chemistry, but we have quite strong application-oriented view. So, and in that sense, the material science is a natural combination. And it happened to be that the department we are working is the name of the department in chemistry and material science. So this the curriculum or this program is a very strongly linked to our department. So we combine these two broad fields. Then second thing I think we are proud of that the focus areas or applications we think are very timely and modern. So we have research and teaching on energy storage, or mostly electrical energy storage, so batteries, fuel cells, and so on. We have an excellent knowledge of thin films, so these kind of very modern materials that are used in the modern semiconductors. So this is a very strong development in material science to make very thin but high quality films on top of different materials, and that's one of our expertise. Naturally, we have the organic chemistry department. We are good at making molecules. We have nanomaterials, nanochemistry, nanomaterial research. And that to remind you that the Nobel Prize in Chemistry this year went to these quantum dots, which are typically of this very small scale quantum or nano devices. So in that sense, we are pretty in a very hot field. We also have soft materials, which is clearly the material research is going more and more to the soft materials, not only polymers, but bio-based soft materials. So there's a lot of activities on that side. And semiconductors, we thought was a little bit old-fashioned, but now in Europe and outside of China, there's a lot of activities to rebuild knowledge of semiconductor industry. So clearly in Europe and US are a little bit worried of the dominance of Taiwan, and we need to rebuild the semiconductor industry. And then one of the key points in our teaching and our research is that we like to make things. So we want to make new molecules, new materials. This is not something that we take existing or something like chemical engineering. Nothing wrong with that. But there, the main point is that they take something like oil or wood and they process it, and that's important itself. But we try to make from molecules, not maybe an atoms, but almost from atoms or very small, simple building blocks. We can make these thin films, new molecules. So this is the very important when someone wants to develop new devices, new technologies. So they need the materials, and our kind of program gives good tools to understand how this is made. Surely the field is vast, we cannot tell everything, but that's, I think, is our strength, is making things. Of course, we need to understand, characterize it. And the last point is that we have very balanced or modern approach. Of course, we have this synthesis. We try to tell how to make things, materials. We need to teach how to characterize them. So it's very important that once you do something, you have to check what happens. So there's some laboratory work, and we also have, of course, the modeling, and we have a pretty strong modeling group. And now we also, of course, use some artificial intelligence tools and to support this chemical development. And for many of the other school master programs in a chemistry school, we are quite strongly research focused or research based. So our teaching has a strong connection to the research we are doing. Then this is a little bit busy slide, and I have to see if there's so this is the structure of our program. So we have first 4 or some compulsory studies which everybody who comes in will take, and then and the research technique, that's basically a laboratory course. It's focusing on certain research techniques. So these are the compulsory studies, and then and this is roughly taking the first half a year of the studies. And then one, or rather early, one need to choose some kind of, we call it paths, study paths. They are not very strict, but they and now, of course, we have quite a few paths, and of course, each of them contains quite many courses. So I don't have now time to go through all the details, but I hope you understand, and I can answer. Let's see if there are some questions. But of course, you see, they have some paths called inorganic materials, and then that, of course, is contains some inorganic chemistry, but they all of them contain some components of chemistry and material science. You can, of course, like in organic chemistry, if you want, you can focus strongly on the organic chemistry as such in a classical way, or you can extend that to like polymer chemistry and a bit more like soft materials chemistry. So in like the first ones, inorganic, organic, physical chemistry, there you have the chemistry focused path, but then you can extend that to inorganic materials or soft materials. Of course, we have a soft material and polymers. The difference between the organic chemistry and soft material polymers, there's still some connection, but then from the soft material, you start a little bit more from material science point of view, and the polymers are more important, has a larger role. And there might be some synthetic organic chemistry, but the names are a little bit guiding the path. And of course, there's the electrochemistry and energy materials that contains the batteries, the fuel cells, and applications like that. And then you have these micro and nanotechnology, which means basically also nanochemistry. So the studies that are focusing not really molecular size systems, but with larger. And functional materials is rather broad. That contains, there's some subtopics, including the semiconductors under the functional materials. So these are the path, and then and in our studies we have certain. This is only 21 on compulsory. Then in the path, of course, if you choose organic chemistry path, you are supposed to study some amount of organic chemistry, and then you can a little bit emphasize of the organic chemistry, polymers, organic chemistry, and modeling, and so on. So there are some variations, and these are roughly 40 credits. Then you get 40, yeah, typically 40. And then you have elective studies, which you can choose rather freely or almost completely freely. Sometimes it makes sense to do in the path. You can take some additional courses to the core path courses. So then you can use the electives within this path, but you can also take some other courses. And like in the functional materials, there's also quite a few courses that are like in physics or electrical engineering school, because most of our people working with semiconductors then they are not in our school. So there's several relevant courses also outside of the chemistry school, and one can, as a student of chemistry, you can take rather easily the courses in some other places in Aalto. And the last half a year is mostly devoted for the master's thesis. So let me see, there's some, sorry, this is very small print on the chat, but I try to see what's in it. Okay, yes, thank you. So the one bit more general, someone asked the elective studies. We cannot, the elective studies in Aalto rules, these are courses that we cannot force the student to do. So they are completely, you can choose yourself. But the key idea that if you take like a certain path, and then you can take so you can use the elective courses. You can, if you want a strong knowledge of organic synthetic chemistry, you take those courses that may end up like 40 credits. And if you then want to learn something of the polymeric materials or macroscopic materials, then you can use your electives on that. So but it's basically we're not allowed to create a path that contains more than 40, or we have, of course, there are more than 40 recommendations in the path, but that's, I would say, is the logic that the electives, it's up to the student to choose. And of course, you'll get academic advisor, and we have some examples what to choose, but so that's the electives is not something that we cannot force the student to take something. Let's see what the other ones. Someone asked the organic and synthetic chemistry, the more information. Maybe at the end I will try to show certain courses, but at this point I'd probably keep. We have now one professor and lecturer on organic chemistry, so there's quite a bit. We have a quite good knowledge of synthetic organic chemistry, and of course there are some NMR, some characterization of organic materials, and there will be a new professor recruiting rather soon, so there will be his or her field will be more. We don't know the person yet, but that a little bit more applied organic chemistry. But we have a strong synthetic organic chemistry group of knowledge, and then we go a bit more on applied. And this I cannot say yet what's there, because the hiring process is still going on. And of course, the organic chemistry one, like you can get jobs typically many companies doing something with organic chemistry. Of course, pharmaceutical industry is one, but there are a lot of other manufacturing of companies that makes different molecules. Finland does not have huge chemical giants like the BASF in German, but our companies are a bit smaller. But yeah, there's a quite clear job path for organic chemistry. I think the artificial intelligence is one question. For example, we have my group, I'm doing computational chemistry. We use the artificial intelligence quite a lot of the data analysis. So we have built several prediction methods based on the computations and artificial intelligence. So we do that one quite a bit. And then we have another group who is doing kind of machine learning potentials. So we have 2 research groups that are active on using machine learning, which is, I think, pretty good from chemistry school point of view. We have a course of artificial intelligence and chemistry as in our teaching, and surely then someone is interested, then of course one can do some individual, or we have this research project, we can go a bit deeper on that. Other questions? Someone asked if we have no. To some extent, there is a list of all. Now, there's no list of all possible electives because you can choose almost any course in Aalto, and that will be hundreds of courses. But what we have in the path, there are. We recommend, for example, if like in most of these things, in inorganic and organic chemistry, you can choose some subtopic, or you can choose like modeling, including, you can do, if you want to do inorganic chemistry and you want to understand how we are modeling them, you can choose this kind of part. So and like I mentioned, there was some of these material science, there are certain elective courses that are out in physics or school, or in the electrical engineering school. So we have, but this list, well, we have certain recommendations. That is about, I don't know how many, couple of tens of courses, and then technically there's a huge amount of other courses that we haven't explicitly listed. So that's why it's not possible to make a comprehensive list of the elective studies. Maybe I go.
Kari.
Yep.
I can see there is a hand up. So there is a person wanting to ask a question. Should we take the question now? Yes, all right. Go ahead.
Can you hear me, Professor?
Yes, I can.
Okay. My major in university is biomaterials. So I want to know, is there any program is suited for biomaterials?
Little bit. Well, we have this wood-based. We have something what we call in Aalto and Finland biomaterials. They are quite strongly wood-based or cellulose-based. So that's one direction of biomaterials. But this is not so much on this chemistry and material science program. I think I forgot now because we have the new names. We have this bioengineering and biochemistry department, and they have so there's some bio, then there's some protein-based stuff there. I don't know the fine details, but this is probably closer to biomaterials. Our material science, we are a bit more. We have soft material. This is typically polymers, some polymers and so on. But this kind of what in a bio-based things, they are a little bit more. I think this is not so much within our program. But what do you mean by bio material? What's your background? Maybe we can go to the next one. So now, of course, typically people are interested in where to get jobs or the career opportunities. This is a difficult question to some extent because I think I don't know if there's any, or there's extremely few people are unemployed. So most of the people find jobs, but then especially on the chemistry and these programs, the spread is very, very large. So some people go to sort of big known established companies, some goes to small companies. So there's a lot of possibilities, but I think the big picture is that because we are quite research oriented and we are focusing on the early part of the development chain. So most of the people go to different type of research and development jobs. So there are many people relate to the I don't know all the companies they are working, but clearly when you want to develop something new and you need the new knowledge, then I think our program gives you a good knowledge, and that's why and I don't think our chemists are not where they don't go typically are the selling type jobs, but they are more from the development, and then the spread is very large. So I don't know the companies. I try to remember, is there any company that has hired several people, but typically people go all over, and of course naturally mostly in Finland but also abroad. And one maybe distinguished thing, again due to this relatively strong research link, then rather quite a few of our students will continue also they do their PhD studies in Aalto. And this is, I think it's important to mention already that, so in a modern world, so PhD does not automatically lead to academic career. So majority of our PhD will continue then again on this research R&D type jobs. So there are very often people or the companies they need some experts having deeper knowledge of something than you can get on your master's degree. But both ways here, the R&D type jobs are quite common from our department. So either you do it after your master's degree, or some people prefer to have also the PhD degree. In Finland, the PhD degree is not needed. In Germany, for example, it's not easy to get a good job in chemical industry if you don't have a PhD. In Finland, we are not yet on that level. Okay, here, this I already a little bit mentioned. These are these are the professors on our department, and grouped on the topic. So there's thin films, this headed. They are, of course, each of them has a quite different size of research groups, but as you see, this ALD is atomic layer deposition. That's kind of our flagship. That's a technique has been developed in Finland. It's very interesting at the moment. So there's a lot of research related to that, and there are several companies in Finland making these ALD equipment, so that's a quite strong. Electrochemistry, energy storage, that's quite clear. Organic chemistry, soft matter, so on. And then on the below are these our modeling persons, and I put them like Antti Karttunen. He's focusing more from this inorganic or solid materials, so it's quite close to. They do a lot of collaboration with Maarit Karppinen. My expertise is quite close to electrochemistry. We are looking at catalyst and modeling. Maria Sammalkorpi, she's working quite a lot with the soft materials. And Miguel Caro is looking more from hard materials, carbon-based materials. So this is roughly, and of course there will be new hiring. One new professor in organic chemistry, one new professor for on the thin film field. So, but these persons are not yet hired. And okay, then there's a professor also related to soft matter modeling. So, but the basic structure is here. But there will be few new phases in the near future. And of course, many of these advanced, we have, of course, the general labs or research methods in the beginning, but then when we go deeper, then we have we have some specialized labs, and they are usually run by the different research groups. So So there's a strong connection with we also sometimes need certain facilities in the electrochemistry lab. Our general labs don't have these tech tools, so then we need to do this some of these laboratory work in electrochemistry facilities. For example, in semiconductors, it's a bit small but in Aalto we have this Micronova. This is the largest clean room facilities in Northern Europe. So this is clearly world-class facilities, and we use that one quite a bit. So on this kind of facility-wise, we are doing pretty well. Well, of course, some other universities are even better than we are, but we are not. That's not bad, the situation. Then this internship, I think in Finland, it's the tradition that people usually get the summer jobs. There are very many, some of them, quite a few people prefer to get the summer jobs in industry. That's possible. Of course, if you are a foreign student, it may be a bit harder to get the industry jobs. They are quite competitive, but it's completely possible. But then most of our research labs, we also hire quite a few students for summer jobs. So you can get not only in our department, but in a whole chemistry school. So there's also quite active, or there's several possibilities to summer jobs also within the chemistry school. And these are very useful. So you get some money, but of course you learn in industry what they are doing. In the research group, you learn their topic. So these are excellent possibilities to learn. And this, I don't remember exactly, but typically some of these summer jobs, sometimes you can get even some credits, but I forgot what's the precise situation now. But clearly this is a very good way to deepen your knowledge. And of course, if you go to industry, then of course it typically helps you to get later on a job, maybe in the same company or some other one, but these are. But of course, this is a little bit challenging because this is a 2-year program. So to be honest, there's only 1 year, 1 summer that this is relevant. Okay, the student exchange. This is possible. Most of our students have the exchange usually before, but this is definitely possible. One need a little bit quite careful planning, and of course, because this is a 2-year program, so mostly you start the first year in Aalto, and then if you're interested in some other places, that's typically on the second study year. And people have done their master's thesis abroad, but mostly people do. But this I don't, unfortunately. Okay, this you need to be contact with people. There's very little. Each person, one person go here, one there. So there's a lot of possibilities, but this is very much individual. And majority of our students will just stay in Aalto because due to that the program is so short that that's a little bit challenging having this exchange at the Master of Science level. It's possible, but and quite a few people has done it. It's nothing extraordinary complicated, but yeah. Then a little bit lighter topic, the student life. Of course, every university typically has quite active student life. Aalto is no exception, and I think it's it's a nice thing that the campus you have not only the chemistry student but all the Aalto students are on the same round. In a chemistry school, we have several student guild like chemistry guild. So these are very strongly recommended to join their activities because there you meet people. not also people a bit outside of your own master program. So, and you can get quite a lot of help. And I think it's important. Well, life is not only work or study, so you need to have some hobbies and to see a little bit other things than just the school books. So I think that's there the Aalto Student Union and the chemistry school guilds are a good starting point. And of course, there's a very strong in Helsinki, in the metropolitan area of Helsinki. There's a lot of possibilities, a lot of different things to do. This it's a bit. There's also in Finland, being a student is quite good. There's a lot of discounts, the health care. So I don't know the fine details, but this definitely, and this whenever you are a student in Finland, you get all these benefits. So it's these are very useful. So slide here is all these. So unfortunately, there's okay. If you click this admission service, you get a lot of information. So of course, the application period. Now I don't remember the date, but it's late on this year. It's quite soon. So if you want to apply, you need to do it quite soon. There's someone asked the English. So this is an English-speaking master program. So you have to have certain degrees of the English language knowledge. If you have done your studies in an English-speaking country, then you don't need it. But but you need to check these details. Yeah, and I think Susanna put these dates. So clearly the deadline yes, it's basically end of November, 2nd of January. So roughly December. Within December, you can apply, and the admission criteria requirements. Yes, what we have done so far, we have a little bit because the chemistry master science degree is new, so we have think a little bit of the admission. So previously we choose people to different chemistry program. We have separate chemistry program and functional material program. So they, of course, chemistry program looks at the qualification and knowledge of chemistry and material science of functional materials of their own things. So now on this new program, we definitely you can apply to the program having a clear chemistry background. So then that's fine. Or if you have a strong material science background, you can also apply. So, and even then, if you have some mixed background, that's also fine. But of course, we assume that you have a good knowledge of chemistry or material science. And then, and every year there's been big challenges. There are, because in a I don't know, there's 10,000 universities and they have huge, very much differences of their bachelor curriculums. So we have to do a little bit of, sometimes a little bit interpretation of what the people has done. There's also one problem sometimes if you have just the course. We have only usually the name of the courses, very little information what the course contain, but we try to do our best. And in a couple of years, we have had quite a few applicants, so it's clear that the selection, I don't remember the precise numbers now, but clearly we got a lot of applications, much more applicants than we can take in. So even you have the suitable background, it's still that maybe that you are not selected because we try to put people on we try to select the best people. So we cannot guarantee that even you fulfill the criteria, you don't necessarily get in. But this is not Harvard or MIT. This is not super difficult. Are there any questions at this point? Okay, there's the chemical engineering. Well, that is usually I haven't been I've been quite a few years on the chemistry, in a committee that choose the chemistry students. So typically if you have the chemical engineering matter, that usually, if it's focused strongly on chemical engineering, that's not usually sufficient. So the point that, but then it depends. If you can have a chemical engineering degree, but it has to have quite a bit of chemistry. So we assume that people know basics or some amount of organic chemistry, inorganic chemistry. So this is sometimes they have been good students, but we didn't find enough, or the chemistry knowledge is rather thin. Then we do not automatically take people from chemical engineering in. We have another different program for those who has a chemical engineering background, but we have selected people who has the name is chemical engineering, but but then some of these people has had a good, or our understanding, sufficient knowledge of chemistry. And in material science, it's also relatively far from chemical engineering. So you need to have if you have a chemical engineering background, there has to be some clear evidence of good knowledge of chemistry or material science. And clearly, as I said, we have another master program for chemical engineering. So that's the point. This is the last slide. Maybe I could. So definitely on this admission service, there's a lot of information, and if you have other questions, we are happy to answer. Yeah, and I think there should be this admission requirement. There's a requirement for the language studies. There's also a requirement for the average grade, and the most important is the suitability of your previous studies. So these are and then of course you need a motivation letter. But this I think should be all on our documents. Sorry, did I say recommend? Sorry, I probably used the wrong word. Not the recommendation letter, motivation letter. Sorry. I think we accept recommendation letters too. But sorry, the important letter is the motivation letter. So of course we are interested, especially because this has a two emphasis. So we want to know: are you a bit more interested in chemistry or material science? So that's one issue, and we need the motivation letter is that we need, and then the recommendation letters, they can be included to the application, but they are not required. So okay, there's a question. Yes, I think you need, if you are studying in Aalto, technically I think you don't need to I think you don't need to apply. You just can choose what master program you continue, providing you have the enough knowledge. But so Susanna, do you know this? If you are already in Aalto, how you to continue? What was because I think it's only those coming outside of Aalto will really apply.
Yeah, I was just answering to Vera that if she fulfills the requirements for the program, I guess they are not ready yet, but she can continue in the program and she can tell the program she wants to continue in the graduate application.
Yeah, and I think if he's not, and we require in chemistry and material science that certain courses has been studied, and these are known. Yes, I don't now remember the list, but there's to get into this CMS master program, you have to have a fulfilled couple of chemistry courses.
All right. I think that's all we have time for today.
Yeah. Yes. Well, there were some questions, but unfortunately, we didn't have time now of them. But
yes.
Okay.
Thank you, everybody, for tuning in. Thank you, Kari, for the presentation. And we look forward to receiving your applications then.
And of course,
all right.
Ask some, just send the emails and we could try to sort them out.
Yes, perfect. All right. Thank you very much.
Okay, thanks.